students, once again welcome back to Tapasya Digital YouTube channel. This is Suhas, your chemistry master teacher. Students, we already launched a new series. It is called as a sprint series. Sprint means with our team coming in one way that we will cover your entire JEE topic with the PYQs in only 15 days. Students, trust me, GOC, one important question will there. This is important, right? If you don't know the GOC, you can't solve any other parts of the organic chemistry. GOC is important. Okay, students, even classically, now basically, I am going to discuss I am going to discuss 3 and 4 important things. First one, it is our isomerism in the last one. In last part, I am going to discuss isomerism. First, I am starting with the basics one, basics, and also then after that all effects, all electron displacement effect with the aromaticity concept, except qualitative quantitative analysis. Aromaticity concept, except qualitative and quantitative analysis, I am going to discuss all things. Okay, my dear students, trust me, watch the video till end. You will get minimum 4 marks question from this entire topic, and also maybe 4, maybe more than 4. Okay, students, come on, let's start. Okay, yes sir, let's start. Students, first, what is GOC? GOC means G for general, O for organic, C for chemistry. Every chemistry people or every PU students, it's a nightmare. Why nightmare? Because it is one of the different one. If you know this one, then your organic is easy. Okay, my dear students, especially organic chemistry is nothing but the study of carbon and its compounds. Correct now? Organic chemistry is nothing but what? Study of carbon and its compounds. Carbon means study of GOC. Now, let's start with the basic one. Okay, I will write the basic one now. First important point about GOC. If you know the entire study of carbon, what is carbon, what is the atomic number, then GOC is easy. What is carbon? Carbon is an element, the atomic number of carbon is 6. What is the electronic configuration? 1s2, 2s2 and 2p. 2p2 now? Yes, obviously. What is the valency? Valency of the carbon is 4. That's why it is called as a tetravalent molecule. What is called as a tetravalent? Very simple. Important. Carbon valency 4. Now, before moving to the effect, you Suhas sir give some important definitions, important terminologies. First important terminology is what is functional group. What is the first important terminology? Functional group. Regarding the word functional group. So let's my definition is very simple. Function. For example, let's imagine you are going with some function like a marriage function. Marriage function you are doing. Then what do you do? What do you guys do? You are ready with nails or makeup and other things. Functions means, for example, what is the difference between monkey and human? Macaca, right? The scientific name of the monkey is macaca, right? But human, Homo sapiens. What is the difference? The function is different. Monkeys can't speak, but human, we can speak, we can think. Correct now? Similarly, functional group means it's a group. What is this one? It is an atom. It is an atom or a group or a group of atoms. Atom or a group of atoms or a group of atoms. Okay, atoms or a group of atoms, which gives the entire idea or entire function of the compound, entire function of the organic compound. For example, what is the alcohol functional group? You can say it's a OH is alcohol functional group, COH is a aldehyde functional group, Ester is there, carboxylic acid is there, and other things. This is the first important definition. Functional group. What are functional group? Functional group is nothing but it is a group. It is a group, my dear students. It will give the entire idea about the function, entire idea about the compound. Idea means chemical properties, chemical properties. This is one of the important thing. It is one of the important one. Then after that, my dear students, we have another important definition. It is called as what? 1 second, I will change the color of the pen. It is called as what is? It is called as a homologous series. What we call that as a homologous series. Okay, homologous series. What are homologous series? Very important subject. They will ask. Homologous series means these are the series contain same functional group molecule. If they contain same functional group, then they will proceed same chemical property. Second important point about homologous series, they have CC same. Sorry, not a CC, CP. CP means chemical properties. Then the third important point, my dear students, first one is the same functional group saying C, and between the two molecules means, for example, series. What is the series? Arithmetic series and other series is there. Now Squid Game is running. Currently Squid Game season 2 is running now. Series part 1, part 2, part 3. Like that. Series means some consist of numbers, some molecules in the some arrangement. Between the two molecules there is a CH2 gap is there. What is there have? CH2. Between the two molecules CH2 gap is there. Then after that, my dear students, and another important point is there. CH2 gap is there. Then after that, what is there? CH2 gap is there, chemical property. But there is an anomalous behavior in their physical property. But physical property there is a gradual changes in their physical property. My dear students, for my students, especially for our Tapasya students, they already know what is gradual difference, what is physical property. Physical property is nothing, but in a physical property, we are going to discuss two points. One is a boiling point, and another one is a solubility. One is a boiling point, and another one is a solubility. In this case, in the case of physical property, what it will happen? For example, just imagine you have a concept of an apple. Two apples you have. You have two apples. To complete this apple, okay, just imagine this is an apple. Okay, no, I think you know that. I am very bad in drawing, guys. I am very bad in drawing. Okay, let's consider apples. Let's say we can consider an apple. For 82 apples, you require 5 minutes. Then for 18 apples, then you require for your only one person. No, sir, it is different. Similarly, if the compound have a different masses, then we require some extra energy that is called as a boiling point or the melting point. Whenever I discuss a organic compound or organic chemistry like alkenes, I hope it's already there. And also, I am going to discuss alcohol, phenol, ethers, and other things. Whenever on the time I will discuss also. Okay, my dear students, I hope homologous series is clear. First important is a functional group homologous series. Now, my dear students, I am going for one important thing here. I will only revise these things because it is only revision session. Okay, I am going to discuss what is the flow of this class. Already I give them one idea. Now, let's discuss exactly zero. So, students, for isomerism, I will make another simple and the trick to find out the isomerism in the next video. Now, in this video, only zero. So, isomerism, I will make it different. One question is coming from isomerism part. Okay, I hope it's done. I hope the introduction, homologous series, and other things are done. In this class, my dear students, we are going to discuss displacement or the intermediates. What is the intermediate and the effects? So, before moving to that one, we have a few important terminologies. The first important terminology is already you done functional group, homologous series is done by the students. The another one important terminology is, what is the next important terminology? Bond breaking thing. Students, we already know we have two type of bond. In inorganic chemistry, we already learned the chemical bonding. One is called as ionic bond, another one is a covalent bond. Carbon molecule, you already know, due to tetravalence, it will form a covalent bond, my dear students. What it will form? Covalent bond. Okay, covalent bond is nothing but mutual sharing of electron. In the case of bond breaking, we have a two type of bond breaking. It is called as a bond fission. It is called as a bond fission or bond breaking. It is called as a bond fission, means bond breaking. Bond cut model. In the case of a bond fission, we have two types. How many types we have, my dear students? We have two types. First one is called as a homolytic bond fission. What is that meaning? Homo. Then the another one is a heterolytic bond fission. Okay, these two terms are very important. Homolytic and heterolytic. Very simple, guys. We have a carbon-carbon single bond. What we have? Carbon-carbon single bond. Homo means this carbon, but to form an electron, to form a bond, this carbon contributes one electron, this carbon contributes another electron. But what exactly happened? The carbon is there, whenever the bond breaking is happened, each carbon carries single electron. What it will carry, my dear students? Single electron. This type of fission is called as a homolytic fission. Okay, homolytic bond fission. Similarly, my dear students, hetero. Hetero means we have two carbon atoms. The entire bond taken by this electron means bond breaking is happened. Whenever the bond breaking is happened, the entire bond it will be taken by or it will do by one carbon atom, and one carbon atom carries positive charge and another atom carries negative. This is what is hetero. The source of HOMO is light. And the peroxides. Very very important thing. Hydrocarbons, some question is there for your JEE mains exam, guys. It is called as a Marconic and anti-Marconic group. On the time anti-Marconic group, we are going to discuss the peroxide by using the peroxides. By using a peroxides, my dear students, peroxides and other things. In the case of a hetero, just you can use a heat and the other nucleophile and electrophile and other things. I hope it's clear, my dear bachcho. Bond fission means we have a two type of bond fission, bond breaking. Homo means exactly they will take one electron, it will form a carbon free radical. Due to this, what it will form, my dear students, carbon free radical. I am coming again with the intermediates. Reaction intermediate means carbon free radical, carbocation, carboanion. I am coming with again carbon free radical and the carbocation and the carbanion. These three are very very important, my dear students. I hope you get some point. Now, what we done up to this, you have also completed the introduction, what is functional group, then the other one is what is homologous series and the bond rates. These are some few important terminologies, my dear students. Now, we are exactly moving for our GOC. GOC means very simple, guys. It is carbon free radical is there. Oh, it will stabilize. Then carbon cation is there, and also sometimes acetic acid. It is an acid. How acetic acid became acid, how the bond breaking is happened, how electron movement is happened. This thing we are going to discuss now. Okay, students. Now, let's move for the next one. What is the next one? And also, sorry guys, I am forgetting that one. Classification of a compound. Entire organic compound classified into two parts. Organic compound classified into two types. One is open chain, then the another one is closed chain. Open chain and the closed chain. In the case of the open chain, my dear students, we are classified as a saturated compounds, and the another one is a unsaturated one. Saturated and the unsaturated one. Again, in the case of a closed one, is nothing but three: homolytic and heterolytic. Homo and heterolytic compound, not a homo. Cyclic and acyclic compound. Cyclic and acyclic compound. In the case of acyclic, aromatic, non-aromatic, and we have a aromatic benzoid, non-benzoid compound, and further. This thing is not important, but here you must also know about what is cyclic, acyclic compound. Say open chain, closed chain, or it is called cyclic, acyclic. Then here we further on classified into further. Okay. Here homolytic fission and other things are important. I hope you get this point. Now, yes. Now exactly we are going for the displacement effect in the organic chemistry. This part is important, especially your 4 months exam. This part is very very important. My dear students, look here everyone. Electron displacement. It is classified into two types. One is permanent, one is temporary. Means polarization effect, polarizability effect. It is called as permanent, temporary. In this case, look here. In the case of a permanent, we have an inductive effect. Mesomeric means resonance effect. Resonance is mesomeric is completely different, guys. I will explain it. Mesomeric hyperconjugation is there. One portion. Definitely there is. Here, inductomeric effect is there. Electromeric effect is there. Inductomeric effect is not that much important. Electromeric effect is important. Come on, let's move for the first one. What is inductive effect? My dear students, concentrate here. What is inductive effect? For example, halogens, we already know. If you are a plus 2 students, halogens, I will consider CX. X means halo compound. Okay, what is X? Halo. In the case of this bond, my students concentrate here. This halo compound is then of X compound. What it will do? It will do that. It will withdraw the electron. Why? Because compared to carbon, halo compounds have more electronegativity. Then what it will happen? This sigma electron is then we already know sigma bond is nothing but single bond, pi bond is nothing but double bond. This sigma electron move towards X. Now, then this X carries partially negative charge. This one carbon carries partially positive charge. This carbon carries partially positive charge and partially negative charge. Here, the process of electron shift along the carbon chain of the atoms due to the presence of electron withdrawing group of electron donating group is called as an inductive effect. Very simple. This is access and withdrawing group. Very simple. Carbon chain. We have one group. Maybe electron withdrawing. Okay, I will explain that one. Electron withdrawing and donating. What is withdrawing group, my dear students? Electron withdrawing group is nothing but it has a capacity. It has a capacity to withdraw the electron from the carbon chain. What is electron withdrawing group? It has a capacity capacity. For example, just imagine your source is standing here. One big person or one fatty person stand on the other side. What we do? We will play a game. Whenever we play a game, what it will happen? That person easily pull out me. He easily pull out me because I am a weak than him. Then he will want. Similarly, electron donating withdrawing group means compared to that one, it is little bit strong. It is more electronegative. More electronegative. It will accept the electron. It will withdraw the electron. Example: halo group in only open chain minus students. OH minus group in only closing in only open chain, not in closing chain. You already know phenols. In the case of the phenols, whenever in the alcohol case, OH group it acts in withdrawing one, but in the case of phenol, it is not that one. Again, halo molecules. Okay, this is about the inductive effect. Or another definition is there: the polarization of sigma bond due to electron withdrawing or donating. Same but different. That means nothing is there. Okay, now let's move on to the next one. This is very important, my dear students. Concentrate here. This is very important. This is very important. Here, group system. These are the electron withdrawing releasing group. This is the order. Look here, guys. It will start with the nRT plus, SR2 plus. Here, this is very important. NH3 plus, NO2. SO2R, Cl, cyano compound, SO2AR, AR means phenide compound, that is nothing but benzene compound, CO2R, carbon, aldehyde, SO2AR, then carboxylic acid, CO2H, nothing but carboxylic acid, my dear students, carboxylic acid, fluoro, chloro, bromo, iodine, and we have that thing. Where is the alcohol, man? Yes, here we have alcohol, people, then triple bonds, then the last we get a benzene. Here it is plus side, it is very easy. Plus side, electron donating groups, or electron releasing group, my dear students, CO2, Cr3, this is the order. This order is very important. For example, where this order is important to observe. Students, here we have a few application, guys. I already said the intermediate. Now, whenever we want to discuss the stability of the intermediate, this inductive effect is very important. Okay, this is the order, this is the inductive effect. I will solve the problem of the inductive effect means it is a movement of sigma electron. What it will happen? Movement of sigma electron is happen from the carbon side to the other group due to its nature, maybe electron withdrawing, donating. This is the order. This thing is done. I hope, my dear Bachcho, this thing is done. I hope you got it clear on this point also. Now, my dear Bachcho, I am going for the next effect. Inductive effect is done. Inductive effect is done. Now, you are also going to move for an electromagnetic effect. My dear students, what is electromagnetic effect? Electron of a pi bond or boost effect due to the sideways overlap. Electromagnetic means it is a temporary effect. Now, my dear students, electromagnetic means look here. This is polar agent is there. It is very simple, my dear students. It is whenever the electrophile is added. Electrophile means electrophile are there. It is very simple. I am going to discuss in the next part. Electrophile means those of the electrons level. Whenever the outcoming is coming, then it will partially arrangement is happen. This is what is electromagnetic effect. Electromagnetic effect that much also not important. Okay, guys. I hope it's clear. Now, temporary effect of the same electromagnetic. Look here. Here I have an example from the positive E effect and negative E effect. Here in the case of positive E effect, my dear students. In the case of the positive E effect, here double bond is there. Upcoming we have the H plus. This H plus we already know opposite charges are attack each other. This category need an anomalic center. Now what it will do? This bond is moving in carbon because sideways overlapping is happening. Both the bonds is happening. That's why this carbon, my dear Bachcho, this carbon carries a negative charge. What it will carry is negative charge, then H plus it can easily attack, then it will form a product. This is what is a positive E effect. Then negative E effect is nothing but minus one it will attack. If attack a positive one, it's nothing but electrophile is attacked. This one nucleophile is attacked, it is a negative one. Very simple. I hope you got that. Now, next move for the yes. Next move for the resonance, it is also called as a delocalization. My dear students, what is resonance? It is a delocalization is something but in a conjugate system, pi electrons are distributed over all of the molecule. Means, for example, my dear students, let's consider one thing. Let's consider here. So, yes, let's consider here. Here, for example, here, where can I consider this? Here I will consider. I will consider here one benzene compound. What I am going to consider? One benzene one. I will consider a one benzene one. Okay. Or we can write calculation. How we can write a benzene one? Like this, you can say sir, like this. Here one bond, here one bond. This is a benzene bond. Now I have some example. It is a, I will imagine it is a withdrawing one. It is a withdrawing or donating one. If it's what it will do, it will donate a pair of electron here. Then what it will happen? This double bond is moving. This double bond is moving, and then it will form another bond. Then you look here, guys. In the case of a delocalization, atoms are standard only. Atoms are present at the same particular point or particular carbon. Never, we are not changing the atoms. But here, what we are changing? We are just changing the electron movement of the electron number of electron. For example, here, if we can say negative means extra electron, delocalization of pi overlap and the p. Same. This is called as a delocalization. What is another name of a delocalization? It is called as a resonance. What is the another name, my dear students? It is called as a resonance. Very important. What is that one? Resonance. I will explain. Now, let's move for the next one. Yes, our resonance. Resonance effect described by the polarity produced by a molecule. Here, guys, okay. NH2 is a donating group. Whenever the electron donating is happening, here negative charge carries this thing. This is called as an electromagnetic effect. The resonance effect is a chemical phenomenon observed in a characteristic double bond of organic compounds. Maybe donating group, maybe withdrawing group. Same what it will happen in the negative now, same is there in the resonance. Okay, guys, here look here. Whenever we move for the types, we have a minus and or minus one. We have a plus and or plus one. Minus means if we consistent what like carbon and group, nitrogen group means finally it will consist there. Withdrawing group. Similarly, minus is there na. Similarly, if we consider withdrawing group, this is that one. Then after that, plus is same thing. Here, this is the order. NO2 is there, carbon and compound, ion compound. The order is very very important, guys. I will write the order. I think it's there here. Okay, I will write the order. Students, my students, what is the order for this one? Here I am going to write here. Plus R and minus R order. Or minus n order is first we come with the nitro, then a cyanide, then a carboxylic acid, then SO3H, then SO3H and carbon. This is the order for the minus n. In the case of the plus n, we are going always a OR, OH. Before OR, OH we have a NH minus. Okay, then NH, SH. This is the order. This is very important, especially this nitron cyanide. You also should be know about nitron cyanide. Now, next one for the energy. Look here, guys. The minimum energy contained most of means the energy is something. Whenever we add something, then what it will happen? The energy increases. This is called as experimental energy, and this one. This is not at all much important. Now, we are going for the another important topic, my dear students. It is called as a hyper conjugation. Okay, I will explain here, my students. Hyper conjugation. Then after that, I will show you. What is hyper conjugation? My dear students, hyper conjugation. I will start with the hyper conjugation. Hyper conjugation. My dear students, you can say, so what is hyper conjugation? We already done with all the other things. Students, hyper conjugation means it is called as a no bond resonance. What is called as a no bond resonance? I will repeat again. Hyper conjugation is called as a no bond resonance. Means there is no change in resonance. The meaning of the no bond resonance is nothing but there is no bond movement is happened. No bond movement is happened, but it is a, we can say that hyper conjugation is a stabilizing effect. It is a stabilizing effect. It means it will stabilize the thing. It will stabilize the atom or a group of, stabilize the atom. Stabilizing effect by using sigma hydrogen. By using what? Sigma hydrogen present in alpha. Present in which position? Alpha position. Very simple, my dear students. I will explain the hyper conjugation. Look here, guys. Look here. The delocalization of a sigma electrons of a lone pair into an adjacent pi orbital is called as a hyperconjugation. It focuses due to overlapping of sigma bond and this is called as a no bond resonance or Baker-Nathan effect. Okay, look here, my students. Here you have one compound C positive charge is there. This C positive charge, this methyl group, it will stabilize the carbocation. On stabilize the carbocation, this is another number of hydrogen atoms. My students, I hope you got this one. Students, here after discussing all these three, now I am going to move for another important topic and also another important inductive effect, isomeric effect, resonance effect. What is the use of this one? I can tell that. I can ask you, what is the use of minus one? Students, for this, we have a few important uses. Means it is used to stabilize the intermediate one. Okay, before stabilization, we must also know about the intermediates one. How many intermediates is there? What is the happening thing? Okay, my dear students. Students, in your organic chemistry, totally you have three intermediates. First one is a carbocation. What is the first one? Carbocation. I will make one column here. Very important. I will show you how. Okay. Yes. First part, carbocation. Then second one is carboanion. Then last one is carbon free radical. Very important students. Concentrate. Whenever the carbocation is there, first important point about carbocation. Carbocation, how it will generate? I already explained the bond fission. It is generated by heterofission. It is generated by heterofission. Carboanion also it is generated by heterofission. Hetero means one carbon completely took the electron and another one is carries positive and negative. Very simple. Carbon free radical by using a HOMO. My dear students, my dear Mitchell, what is carbocation? Plus is nothing but it have a less than one electron. It have a less than one electron means what is the basic? We already know by using octet carbon carries 8 electrons. That's why it will form a covalent carbon. Whenever the hetero bond, here I will consider this one. This carbon carries the entire electron. Then what is the valence of carbon minus 1? Basically, you can say that such what's the valence of carbon is 4. Then it will form a 3 bond with that one and other things. Now, whenever 8 electron is there, the carbon or take one electron, take the entire this 2. Then how many electrons remaining in carbon cation part? We have 6 electrons. The remaining electron is 6. In this case of the carboanion, extra one is like 8. In the case of the carbon free radical, 7. Why? Because HOMO means each carbon has one extra. One extra. 6 plus 7. 7 minus 27. Okay, I will say. Then in the case of hetero, we already discussed that. Means, just imagine I am a carbocation. I have my electron donating. What I am doing, I will stand here. Electrons are revolving around me. Electrons forming one compound around me. One seed around me. On that time, carbocation stability increases. Means carbocation stability is increased or it directly proportional to the plus I effect. Okay, plus I effect. And also carbocation stability is directly proportional to the plus M effect. And also it is directly proportional to the hyperconjugation. Means hyperconjugation means total number of sigma hydrogen. Total number of sigma hydrogens. Okay guys. Then in the case of carboanion is directly proportional to the negative effect. Carboanion is directly proportional to the minus effect. Carboanion, it is inversely hyperconjugation we are not considering. In the case of HOMO, same thing. Means carbon free radical, same what we carry in the carbocation. Same thing. In the case of a carbon free radical, directly proportional to the plus I effect and also directly proportional to the plus N and directly proportional to the free radical. My dear students, directly proportional to the hyperconjugation. Okay, I will show some problem, you will get answers. Okay, this is about the intermediate stability. Okay, I hope you got some idea. If you still face a difficulty, my dear students, in comment section, the comment section is yours. Commenting and ask the doubts. I will clear in Tapasya. Otherwise, you can visit the Tapasya Center. It is present in or it is there in Karnataka Road. Karnataka Road is there. You can visit the center. Okay, clear. Now, okay, guys. Now let's look for another topic. What is that another topic? The another topic is an aromaticity topic. What is the another one? Aromaticity. Okay, guys. What is the another one? It is an aromaticity. What is aromaticity? Very important. I think this is the last concept of your today's class. Isomerism binding. I will give and brief introduction about the isomerism in the end of the class, end of this session, and also I will give some idea or I will explain next video my students. In the those times cyclic, acyclic is there. In the case of cyclic homo, hetero is there. In the case of acyclic further on benzoic compounds is there. Means aromatic compound. What is aromaticity? How to find aromaticity? Students, to find aromaticity, we have three important. One first point is the molecules must be cyclic one. Okay, the molecule is cyclic one. Then the second important point, my dear students. First one is cyclic one. Second important thing, carbon is must should be sp2 hybridized. Carbon is must should be sp2 hybridized. Then after that, it is planar. sp2 means it must should be planar. Then the other important point, cyclic is done, sp2 is done, planar is done. Then what is the another important thing? Another important thing, it must should be follow Huckel's rule. Must should be follow Huckel's rule. What is Huckel's rule, my dear bachcho? Huckel's rule means 4n plus 2 pi electrons. What it will follow? 4n plus 2 pi electrons. This is the Huckel's rule. 4n plus 2 pi electrons. Very important. I hope you get it. Cyclic, sp2, planar, Huckel's rule, and the Huckel's rule is one. For example, my dear students, the compound follows a cyclic condition, sp2 planar, but it will not obey the Huckel's rule. I will repeat again. It already cyclic one. It is a planar. It is a Huckel. It is not obey Huckel's rule. Then those compounds are called as anti-aromatic. What we call as anti-aromatic. We call as anti-aromatic. Okay, guys. Then, if this obeys all things aromatic, if it's failed to obey cyclic, okay, it is cyclic but not planar one. I will give another important trick here. Planar means double bond minor bachcho. Planar means sp2 means double bond. Alkene na sp2 means alkene na. Very simple. If double bond is there, you can easily say that. And also, it must and should be resonance. Resonance is the bond is must and should be there. Okay, students, these are the three important things. Now, we have to do three aromatic, anti-aromatic, non-aromatic means it is not a planar one. In an exam, especially for your GE, they will ask stability order. Means they give a 4 which is the aromatic in this following, or which is the thing they will ask. In the case of the stability, aromatic is the most stable one. Then after that, non-aromatic came to compete. Then after that, last we have an anti-aromatic. A for not allergic. A means anti-aromatic. A is least one, aromatic, non-aromatic, and the anti-aromatic. I hope you got it. This is about your aromatics. Okay? Students, basically this video is only for one shot one. One shot means that revision one with the PYQs. And also my dear students, if you want the complete explanation, in this description, exactly this video description, I will give one link. This link give an idea about, okay. Students, this is stability order. Come, let's solve some problem based on this. You will get an idea. Okay. Now, let's take our favorite benzene one. Benzene ring. Our one and only benzene. This is our benzene one. It is also written as like this. Calculations. How can we write? Calculation structure. This is the calculation structure. My dear students, what is the first important condition for the aromaticity? First important condition for the all carbons present to be sp2. Means it is a cyclic one. Yes, it is a cyclic one. Yes, sir, it is a cyclic. First point is clear. It is cyclic. Then the second point. Second point is all carbon are sp2. As it is alkene is there everywhere. Yes, sir, it is an sp2 carbon. All carbon are sp2. Then the third point. What is 4 plus 2 by how it will get? Totally 6. 3 more is there is nothing but 6. N will become 1. N is a whole number. N is a whole number. N. It is also a obsessive of alpha. Then it is an aromatic. Similarly, let's try this one. What is the name of the molecule, my dear bachcho? What is the name of this molecule? The name of the molecule is. What is the name of the molecule? Tell me. The name of the molecule. We have a three aromatic. Pyrrole, pyridine. This is a purine one. What is this one? It is a purine. Purine means cyclic is there, a cyclic bond is there, sp2 is there. So look here. This lone pair is there. This lone pair is present inside the ring. If it is present inside the ring, then this lone pair it involves in the resonance. This lone pair is more here, then this thing is happening. Very important thing. Then how many pi electrons we have? 6. Then n will become 1. That's why this is the aromatic. I hope you get an idea. Now let's give an anti-aromatic one example, guys. Very simple. and the this way. My dear students, look here. In this two example, this carbon is known as sp2y. It is a sp3. Then the compound is placed in a. It is cyclic, but second one. That's why this compound is example for non-aromatic one. It is example for what? Non-aromatic one. Non-aromatic. Similarly, this cyclic compound, cyclobutane. It is also sp2, but what happened there is a 4n plus 2. 4n plus 2 is given by 4, then 4n is equal to 2, then n value is off. N is equal to off means nothing but fractional. It is not always the actual root, that's why it is example for anti-aromatic. This is example for anti-aromatic. I hope you get it here. This is about your entire aromaticity concept and the other. I hope it's there. I hope it's there, my dear students. Now, let's go for the next one. Next one is our beautiful electrifier nucleophile, very important. What are electrifier, my dear students? Electron lovers. Nucleophiles is nothing but nucleus lovers. Neutron means nucleus lover. Okay? What is the definition? This sort of positively charged neutrons deficient means they need electrons. But these are many nucleophiles. Sorry, nucleophiles need electron. Electrophiles need electron deficient atom. Here example BF3, AF3. BF3, AF3 you can say as a Lewis acid. Electrophile is nothing but Lewis acid. Nucleophile is in this space. You can say like that also. Positively charged spaces, negatively charged spaces. Normal definition. Then let's summarize the entire thing. Here look at first point. Acidity and basicity can be predicted by inductive effect. How will be predicted? Let's solve the questions you will get that. Students, my dear students, inductive effect predictable or the acidic character it is predictable by. If more plus I effect, it is basicity is more. More is more negative I effect, is acidity is more. Resonance effect stability. Then hyperconjugation stability of a sigma bond by using that one. Then the negative hyperconjugation this one. Students, this is the order. Then this we need to discuss. Here, my dear students, let's take a few examples related to the hyperconjugation one. And the otherwise we can set down for basic character or acidic character. So, my dear students, the first important question is based on the acidic character. I am taking a nitro group first. Nitrobenzene with the presence of a one OH, one of the important question. Then similarly, I will consider the same compound with the same number. My dear students, whenever I explain that mesomeric effect, I said you, students, minus M effect is there, carboanion stability is more. Minus M say carboanion stability is more. If carboanion stability is more, then more acidic character. This thing. Whenever here look here, whenever we write a minus M effect, nitro group show a more negative M effect. That's why we can say that this have a more acidic character than this. This is the actual criteria. Means acidic character means minus students. If minus I effect is more, otherwise I will do one thing, guys. I will make one column now. You need to remember this column now onwards. You need to remember this column to solve the entire GOC problem. First important thing, if you want to discuss acidic character, I will consider as A. Acidic character means plus I effect is more. Sorry, not plus I effect, minus I. Which is more? Minus I effect is more. Basic character, if you want to discuss basic character, plus I is more. If acidic character is increases, minus I effect is more, then it is directly proportional to the K and dissociation constant. Then it is K increases, then pKa decreases. This is the actual order. Then similarly, if plus I increases, Kb increases, then pKb decreases. This order is very, very important. My dear students, I always said that reaction intermediate stability. Whenever the reaction intermediate stability, my dear students, you must also be more about what is the order, the exact order in this case of the stability character. In the case of the exact stability order, you need to consider this. First, you need to go with the resonance, then the hyperconjugation, then the inductive. Okay, this is the order based. Resonance is there, it is always stable, or it is always stable. Very simple. I hope you got this one. I will move aside, take a screenshot of this one. I hope it's done. My dear students, I hope it's done. If you want to speak today, I will share in the Tapasya Live App. In the description, it is there. The app is there. Please subscribe and please get it in the app. Okay, please download it and please get it in the app. My dear students, I hope you done with that. We are coming to the last point of view GOs in this type of reaction. In the case of the organic, we classify the entire reaction into three types. First one is substitution, then elimination, then after the substitution, elimination, and the other one, what we are called as a substitution reaction, elimination reaction. What is the another type? In the case of the substitution means we will substitute something, elimination. Okay guys? Okay. Everyone okay? Let's discuss the separate one. First reaction, type of reaction is a substitution. In the case of the substitution, we have further classified into electrophilic substitution, neutrophilic substitution, and the free radical substitution. In the case of elimination, E1, E1, E2, and the E1 CD. Okay, E1, E2, and the E1 CD. And also we have a rearrangement reaction, students. Rearrangement reaction means intramolecular rearrangement is there, intra and inter. Inter-rearrangement reactions there, and also further we have a photochemical reaction and other things. Once again, guys. Okay, students. Finally, we done with the aromaticity and other concepts, and let's solve for the PYQs. Before going to PYQs, my dear students, we must have should be know the type of a reaction. In the case of a organic chemistry, we have a totally three types of reaction, my dear students. One is a substitution reaction, or I will start like this. Type of a reaction T. It will classify into three parts. It will classify into three types. One is substitution, then the elimination, then after that is the addition. Students, I will give one important thing here. Substitution means alkane to alkane only. Substitution, in the case of a substitution, further we classify into nucleophilic substitution, electrophilic substitution, and the free radical substitution. In the case of elimination, totally we have a E1, unimolecular E2, and also we are going to discuss E1C. Okay. In the case of addition, we have two types. One addition reaction by using molecule, and the another one is an anti-molecule addition. So let's I will give another important detail. Substitution means substitute something. For example, we have a carbon one. If it replaces the one hydrogen by using any chlorine and other one, it is called substitution. Elimination means we will eliminate that one. We are not doing anything. In the case of addition, we will add one molecule. And the molecule means alkene to alkene. Here alkene to alkene is only there. Here alkene to alkene. Okay. Here it will change alkene to alkene, alkene to alkene. This thing is about a type of reaction. I hope it's there. I hope it's there. Okay. Then nucleophile electrophile is there. Then after that this thing is there. Now let's move for the PYQs, my dear students. First important question. It is asked in the JEE 2022. In the second field, the correct stability order of the following resonances. This is the order. Here look here, guys. Order means, for example, just imagine you have a capacity to hold 100 kg. Then we can put in another 50. And if you have a capacity to hold 50 kg, then you can't hold that 60 kg for that one. That's thing. Here look here. We have a 3-1. Here we can easily set the answer. I will give it in seconds. Set the answer, my dear students. What is the answer? Let me know. Okay. Students, the answer is here. The third part is a stable one. Then the third, it is there in only one option. The answer is not. Why is that? Because look here, this is a stable one. The structure we can write like this: CH3, CH, double bond, CH. Then RTM molecule is there. RTM molecule they will access a little and the C double bond is more electronegative. Then what will happen? Then the second one. Look here, what it will show? It will move here, then it will carry negative charge here, then this carries also negative charge. That is a second stable. Second order one stable. Here look here. Here what it will happen? How the resonances will happen? My dear students, look here. I will show you how resonances happen. Here, this bond, this bond is moving. If this bond is moving, then this bond is moving, then it will carry cycle. That's why the answer is option. I hope you get the point. If you have a doubt, don't worry, let me know. Comment. Next question. Correct order of the basic stage of a pyramid is one of the important question it is asked in the again JEE 2024 only. Correct order. Let's write the structure first. Best let's write the structure. Pyro means we are done. Pyridine. Let's set the pyridine structure. Pyridine means, my dear students, it is a non-aromatic compound. Look like this. Pyridine. 5 pyridine. Then the next one they give pyrrole. This is the pyrrole one. Okay, this is the pyrrole one. Then after this thing, they are giving a pyridine. Pyridine structure, my dear students. We need to choose the basic character of this. My dear students, basic means the lone pair is there. The lone pair can easily abstract a proton or donation of an electron. A lone pair is easily. According to this exactly pyrrole molecule, what it will happen? This lone pair is involving in the resonance. That's why the answer, what we can give an answer. The answer is pyridine shows a more basic character. That's why the answer is option D. Option D is the correct answer. I hope you get it. The next question. What they are asking here? What they are asking students? Look here guys. They are asking for the given compound the correct order of increased pKa value. My dear students, pKa means I already said you. Acidic character, reverse of acidic character. My dear students, here we have 5 options. Look here phenol. NO2 is a strong withdrawing means it has a least pKa value. Least pKa value, then that's why the option is B. B, then again D is come, then after the D, C, A, E. Yes, obviously, it is compliance. That's the answer is option. Okay, I hope it's got it. Next question. Then irritability. We already told you this one. What is the answer? Let me know this. This is for your homework. Let me know your conversation. Okay, I hope you will tell me the conversation. Next question. The correct sequence of acidic strength of the following aromatic acid the order is. We have a tree. Totally we have a tree. It is also in the tree again. Carboxylic acid, ethanoic acid, then the methanoic acid, then we have a carbonic acid, and the formic acid. You already know, my dear students. The first one is HCOOH. HCOOH because of we can say like this. Then after the bulky group increases, then the positive ion increases, then the basic character decreases. Acidic character. That's why the answer is C. Here only CH3 is there, here 2 CH3 molecule is there, that's why the answer is option C. I hope you got the one. I hope it's clear. Okay guys, now let's move for the next question. Okay, IUPAC of the hydrocarbon, one of the easiest one. For a IUPAC nomenclature, we need to count the total number of carbon atom present in a node. Correct now? Let's consider this time 1, 2, 3, 4, 5, 6, 7, 8, 8 chain is there. 8 chain is there. Totally second, 3, 4. 2 comma, okay, ether is there? No. Guys, 2 comma 5. Oh no, 2 ethyl. 1 second, guys. Okay, let's count the total number of carbon atom. Look here. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Then 1, 2, 3, 4, 5, 6 is happened. 1, 2, 3, 4, 5, 6, 7 is happened. No. Then 8. Where is octane is there? Yes. 3, 4, 7. Here there. Option C is a correct. So very simple. You all know. Next, the statement type question is basically from the qualitative quantitative analysis. Guys, I have not done this one. I will discuss in the next one. Then after that you can do. But I will the Zelda's method is not applicable for SQ. It is method is applicable as statement is true. The nitrogen present in pyridine can easily convert into. Statement 1 is true. Statement 2 is false. Okay, the answer is option. Now, the questions. Okay. Last we remind me 3 questions, guys. The question is the total number of aromatic compounds among the following compounds. You can easily say that. Here looking at it is a numerical one. It is not an aromatic one. Why? Because my dear students, this is that one. Then here, if we double note, this is not or not. This one is aromatic. Aromatic or non-aromatic. Let me know. This one. This one is aromatic. Totally 1. Here this is also aromatic. But 4n plus 2, 8 is there. 4n plus 2 is equal to 8. But n value is not. This one is anti-aromatic one. This one. 4n plus 2 is equal to 4. Again, it will not generate only answer is 4. Answer is no. I hope it's clear. The same. Next question, my dear students. Next question is okay. Which of the following or aromatic? Here, which of the following is option? The answer is C. Option C and option B. The answer is option B and C. We can easily say that for aromatic one. More aromatic is there. In the given compound, the number of secondary carbon atoms. My dear students, I am going to explain the secondary primary carbon atom. What is primary one? What is secondary one? My dear students, I will explain. Primary means 3 hydrogen atom. Secondary means 2 hydrogen atom. Tertiary means only 1. Quaternary means there is no hydrogen atom. Correct? Look here. Here how many secondary is there? Means secondary means 2 co-hydrogen. Here we have it to 1. This of the tertiary primary one we are not considering. Then after the any other one is there, CH3 is there. CH3 is nothing but like this. CH3 is there, no, this is also not one. It is a tertiary one. The answer is very simple question. Very simple question. GOC is very simple. This is about your PYQ smart question. Thank you so much. This is about your GOC. If you need any topic, any specific video, one shot video, let me know in the comment section. Thank you so much for watching the video till end. And bye. Stay tuned, Tapasya, and subscribe to the channel and share the channel. Okay, bye.